Alright, so today we are going to have a look at rectangular and polar form, how to convert between them, and pretty much an introduction to polar form of complex number. So you can see on the right here, the diagram, the number is represented as a vector, which is an x and y component and an angle. So this is the rectangular form of a complex number. And if you use SOHCAHTOA and just write down the sine and cosine components of this particular vector, if you use x and the value r, which is the modulus, and if you've forgotten what that is, modulus is the value of the vector, that one. So modulus is pretty much x square y square square root xi. So if you write let's use a different color. If you write the sine and cosine ratios, so cos theta equals x over r, and sine theta equals y over r, and therefore x equals r cos theta and y equals r sine theta. Now if you substitute this in the rectangular format, which is that one, you end up with z equals r cos theta plus I r sine theta, and that's pretty much the polar form of a complex number. But we don't write it like that, we simplify it, and so we simplify it to z equals r cis theta, which pretty much means that. Cool. So that is the polar form of a complex number. Next we look at some examples in how to plot that on an Argand diagram. So let's have a look at three different polar forms of complex numbers, u, v, and w, and analyze them and see if we can plot them on an Argand diagram. So let's say that's my Argand diagram. On an Argand diagram, the x-axis is the real numbers, the real component, and y-axis is the imaginary component. Alright, so if we look at a generic form of our number, then I'll just change the color. That is your modulus, and that is your argument. So modulus is pretty much the length of the vector. So if you want to plot u, pi over 4 is, in your mind you can do a calculation or use a calculator. 180 divided by 4 is 45 degrees. So any positive angle is taken from the positive x-axis that way up. So 45 degrees goes somewhere like that. That'll be the value of 2, and that is your angle. And that's how you represent it on an Argand diagram. For visual purposes, also for problem solving later. Okay, v. There's no number in front of this, so that means the modulus is 1. Okay, 2 pi over 3 would be, in terms of angle, would be 180 times 2 divided by 3 is 120 degrees, which falls in the second quadrant, and therefore it will be smaller than 2 and positive, so that would be a theta, 2 pi over 3. So this is u, this is v, and an angle which is negative starts from there but goes in the opposite direction, which is clockwise. So 3 is your value, and negative 2 pi over 3 would negative 120 degrees, so 90, that's so 90 and a bit more, and that will be your w, which is starting from there, so negative 2 pi, and that's how you represent polar form. of a complex number on an Argand diagram. Cool. Let's have a look at converting polar to rectangular. Alright, so let's convert 2 minus 3i into polar form. So firstly, what you should do is you should actually draw an Argand diagram. And that's your imaginary, that's your real, and then start finding values and plot it so you can have a visual. So the modulus R will be 2 square plus 3 square, which will give you 4 plus 9, which is square root of 13. Cool. So the modulus is square root of 13. To find the angle theta, theta is tan inverse of so you have to plot this on the so the real component is 2, so 2 is let's say there, and negative 3i, so minus 3, so pretty much your vector would go something like that. That's it, and your angle goes like that, theta, so you're going to find theta. So theta is tan inverse of negative 3 over 2. And if you plug in the calculator, you end up with negative 0.983 radians. Cool. So the general form of the polar form is z equals r cis theta, which is z equals, substitute, the modulus is square root of 13 cis negative 0.983 radians, and that's your polar form of 2 minus 3i. Alright, let's convert the other way. So let's convert polar form into rectangular. So z is given as square root of 2 cis minus 3 pi over 4. If you have to convert into rectangular, you have to write down the full form. So z is equal to r cos theta. So in this case, it'll be plus I r sine theta. And so if you substitute, you end up with square root 2 cos of minus 3 pi over 4 plus I square root 2 sine minus 3 pi over 4. Make sure your mode in your calculator is in radians. So square root of 2 times, you'll end up with 1 over root 2. So how would you know that? Is you have to know your special triangles and it'll come up as 0.707, so on. So there's certain numbers which you have to be able to figure out and look at and know those are the exact angles, and so we can have a look at that later though. So that's 1 over root 2, sorry, just give me a sec. So okay, plus I square root of 2 times negative 1 over root 2, sorry, I missed a negative here as well, and therefore the square root of 2 will cancel. I'll use a different color just to show. That'll cancel with that, that'll cancel with that, and if you simplify, you'll end up with minus 1 minus I, and that will be your rectangular form of the complex number. So the only thing extra you have to kind of remember here is the special triangles, which if you have issues with, we can have a look at later. Okay, thank you for listening.